once a acknowledgement packet has been sent, what happens is you need to finish this session when your task is over, and that you send by sending a finish flag or a reset flag, right? So this is how a TCP connection is established and then broken. Now, one of the most common protocols in the entire internet and TCP/IP network is something called the DNS, or the domain name resolver, or domain name resolution. Now, domain name resolution is a protocol which helps you, I will say, not transform, to understand computer systems, to understand human readable form of addressing. So now, if I tell you that, Google's address, if you want to type google.com, don't type google.com, type a IP address 127.22.26.72. For you to remember each and everything number wise is not possible, right? So that's why human notation is, okay, let's go to www.google.com. But then computer systems do not understand, for them, this is a complex language. So what happens is computers use IP address in a form of binary address, okay? And this binary is given to you in a notation, which is again human readable, okay? So what happens is once you type google.com, the computer system sends a query and asks who is Google, google.com. The reply which comes back is it is 127.22.26.72, okay? That is called a DNS reply. And this is called a DNS query, right? Now, what actually happens in a DNS system is you are in part of a network, right? And your router is connected to ISP. The first stage where you can have a DNS is your internal DNS address, DNS server, right? This DNS server can be synchronized with the ISP's DNS server. In turn, the ISP's DNS server, this is your DNS, this is ISP's DNS, and this DNS is part of the overall DNS architecture of, right, a hierarchical DNS system. Okay, so what happens is once a user connected to your network wants to know the address of a particular website, okay, the first thing that it does, it searches its own database, which is called a host file. The host file has addresses of the recently visited websites or recently visited services. If the address is not there, it goes to the first step, that is your internal DNS server, if you have one. If you don't, then the query is sent to the ISP's DNS server. If you don't, then it is sent to the open DNS server, whichever is the part of your DNS hierarchy to which your internet service provider has subscribed to. DNS helps you resolve the address into IP address. Okay, that's the simple thing. The address is called FQDN, fully qualified domain name. Okay, wherein the Google is the domain name and the subdomain is www. www is called the World Wide Web. Okay. DNS and ARP are similar. ARP is at layer 2 at the switch level. DNS is at the network level. So whatever attacks happen at layer 2 can be replicated at layer 3. Now, suppose your computer has a host file and I corrupt this host file. You know what is the most simplest way of attack? I deliver you a Trojan. Okay, this Trojan puts a small IP address, okay, into your host file. Okay, and because your IP address is there in the host file, your computer system communicates, and I give your computer address that sp.txt.com. Now, when it goes to the host file, it finds sp.txt.com at some IP address, and it establishes a connection with the host. That is how Trojans work and help themselves in creating a command and control network with some hacker setting outside. Now, one of the easiest way to find out any unauthorized communication on a network is to scan your network for such kind of communication. Okay, so if you are seeing that there is some irregularity on your network in terms of IP addresses, and that's what SOC analysts do, they continuously see the reputation list of IPs that the packets are going out of the network, right? So it is the most simplest way of finding out if there is some penetration into your network is to see what is the outwardly traffic from your network. Okay, because nobody can transport any kind of data outside the network without some kind of an IP address resolution. And that's why monitoring DNSs will help you in understanding if there has been some intrusion in your network. How DNS works is, I told you, it has initially will go to the local DNS server, then it is part of a hierarchical DNS architecture to find out which server knows what is the IP address of a particular website or a space where you want to send your packet to access. Okay. Now DNS earlier, this DNS infrastructure was very, very insecure because it was working on HTTP. It was not working on HTTPS. So what happens? Hackers used to go to your server and corrupt the DNS table. Okay, they could attack your computer and corrupt the DNS table on your file or the DNS server. But now DNS architecture is been secured by a protocol called DNSSEC. DNSSEC, what happens is, once your computer sends, okay, I want to know who is google.com. This request reaches your server. Okay. Now the server sees this request, okay, and resolves that request from another server, which is the master, its DNS server. What happens is, whenever this google.com information needs to be there in the tables, right? They have to query the google.coms. They want to know that google.com is equal to 8.8.8.8. Now this entry has to be made into all the DNS tables. Okay. Firstly, somebody needs to tell them that the authorized IP address of Google is 8.8.8.8. And that is done by someone called the root DNS. Now, whenever I'm sending a query to a DNS server, now it is done on HTTPS tunnel. It's not done in open. Earlier, it was done in open. So that's why there was access easily available. Second thing is, whenever one server corresponds to another server, they check the PKI for authenticity of this particular server. They try to find that this server is not a attacker's DNS server or a spoofed DNS server, and that is done by confirming their public address and private IP address through the PKI. Okay, understanding this much is more than enough, because now if you have to see that I want to know some information from another server, how will I know that I'm picking up the information from the right server and that server is not compromised? And there comes the concept of digital signature. I will first check whether his digital signature is valid. If it is valid, then only I will take the information from that server. Okay, so it is all about identification, authentication, and authorization. So I want to know whether you're the right person to give me the information. You have to apply that IEEE concept. DNS poisoning is simple. I corrupt your DNS table inside your database, and if I corrupt it, then my data will be, then I will be redirected to addresses which are actually false. Okay, basically DNS poisoning refers to poisoning the DNS table inside the DNS architecture, whether it's in your own local PC or on the entire DNS architecture. Now, what are the simple techniques by which you can protect your DNS architecture? Firstly, your host file should be protected. You should have anti-malware, anti-Trojan, anti-malware systems on your PC so that your host file is not corrupted. That is first part. Secondly, on the network part, your servers which are handling DNS data, they need to be hardened. They need to be resilient to any kind of attack on their DNS architecture. And finally, the way DNS servers communicate to each other, that should also be protected. And how do you protect it? By having a secure tunnel. This secure tunnel you can implement using SSH, using IPsec, using DNS over HTTPS. Okay, and that is nothing but DOH. Okay, there are many other ways. You should know the broad architecture that how you can secure your DNS architecture. right? Now, two techniques which are DNS over HTTPS and oblivious DNS over HTTPS. Oblivious DOH means it is always on. Two servers are connected to each other, always on an HTTPS protocol. Okay. And normal DOH means whenever it needs data from the second server, it will create a HTTPS tunnel and get the DNS information. Okay, that is the only difference between DOH and oblivious DOH. Now, regarding DNS is something called domain hijacking. Now, if you look at how domains work is, firstly, you have to apply for a domain. You have to buy a domain name. So there are a lot of registered entities which give you a domain name. One of them is GoDaddy, right? So you go to GoDaddy and you buy a domain. You bought a domain name. I bought a domain name www.learn.protect.io. So learn is the subdomain, protect is the main domain. I've bought that domain, and after 1 year, I forgot to renew the domain. So what happens? There are guys sitting who are watching as to when does a particular very renowned domain goes out of renewal, and then they try to buy that domain name and renew it. That leads to your domain hijacking. Somebody has hijacked your domain because you forgot to pay the domain fee, and you forgot, and they will. So what happens is, these days domain registrars, they keep sending you mail 1 month, 6 months prior that your domain is about to expire, your domain is about to expire. Okay. And from wherever you have bought the domain, please ensure that you protect that domain from wherever your GoDaddy account. If your GoDaddy account gets compromised, then your domain names get compromised. Okay. So you should set up auto renew, and payment method should be always updated so that your domain doesn't go out of your hand. Okay. Now, something related to domain is, now say I want to visit your website, google.com. Okay. Now, if I want to fool users to come to a unauthorized website, that for phishing, right? So what I do, I create a similar looking website with the name google.com. Now what happens, there are many times when you type Google, by mistake you type, you have sticky keypads, and you type Google 3O at times. So what happens is, you will go to a website which looks exactly like Google, but actually the website will be G with a triple O. Hackers, they want you to visit such websites, and they find out common websites which can have typo squatting errors. Basically, they are squatting on your typos. Okay, so you do a typing error and you reach a website which looks exactly like the website you wanted to go. You wanted to go to onlinesbi.com, and by mistake you typed onlinesbii.com, and suddenly you land up on a website which look exactly like SBI, right? So they are waiting for you to carry out typo errors. Once you reach, you end up giving their username, password, and OTP also. Why? Because there is somebody created a simultaneous session with the actual website. Okay, very common attack. Then people also do, typo squatting. Oh yeah, typo squatting is there. Homograph attack is people create, lookalike websites. Okay, typographic is where they are waiting for you to do a typing error. Homographic attack is where I am looking for domain names which look similar to the original name. Like it's google.com, right? I open a website with looking like goo with a capital E.com. Okay, so what will happen is, it will give you, they use Latin letters. So if you use Latin letters, people will come to you thinking that you are Google. I've opened a website with the Latin letter, because L in Latin is 5 or 4. So I've used L, I use 4. So that will be taken as a domain name, and then I can fool you to come to my website. That's called a homograph attack. So these are the attacks happening at the DNS level, if you see that, at the domain name level. Then you can also do something called URL hijacking. So what is URL hijacking? Okay, I take you to a website. Okay, I take you to a website which is my protect.io. Okay, and then when you reach here, what happens is, you are redirected to some other website. That means somebody has compromised my domain name and redirected this to some other website, okay, which might be a lookalike, which might be some malicious website also. Okay, such kind of attacks are called URL hijack. Somebody has hijacked my URL. Okay, then you can have clickjacking attacks, wherein you go to a website, for you there is nothing, you by mistake click somewhere and you are taken somewhere else. Why? Because that area has a hyperlink which is not visible to you. You by mistake, you are forced to go and click somewhere which may look like a very genuine click, but it will take you to some other website. Okay, that's called a clickjacking. You have hijacked his click. Right. Okay, now what is IP networking? Okay, you have to understand IP networks. Now, what happens once we do TCP/IP networking is it has an address space. IP has an address space. Okay, it is a 32-bit binary address. That is the first binary space 1, 2, 3, 4, 5, 6, 7, 8, then dot, then again 8 spaces, then dot, then again 8 spaces, then dot, then again 8 spaces. Okay, these 8 spaces, okay, if you see, denote your IP address 192.168.1.254. Okay, so this is the IP address. Actually, the computer systems understand its corresponding binaries. Whatever binary number is there for 192, right? For 168, whatever binary number is there. For 1, it is 00001. And for 254, it will be 1.0.111111. Right. So what I'm trying to say is that total space in IP is 2 raised to the power 8 plus 2 raised to the power 8 plus 2 raised to the power 8 plus 2 raised to the power 8. That means total 2 raised to the power 32 total combination of IP version 4 addresses are possible. Okay, at any one given time. Now you can have address from 0.0.0.0 to 255.255.255.255. Okay, this notation is called CIDR notation. Okay, this notation of showing IP addresses of binary in human readable form is called CIDR notation. Right. IP version 6 was created to come over the anomalies of IP version 4, but somehow it has not been successful because of certain reasons, which I will, explain to you further. Now, IP version 4, what happens is once you do this IP version 4, read about this IP version 4 addressing, what you will come to know is that IP version 4 has 2 raised to the power 32 address space, out of which 192.168 series is kept for private addressing. That means anybody with 192 series can use this address space for internal communication. They do not need to, this packet will never be routed to the internet. Okay, similarly, 10 DOS series is also stored for private networks. Okay, and 172.16. something also is saved for private networks. That means these 3 networks addresses, the moment router sees them, it will not let it go to the internet. Rest all packets it will route to the internet. That means you can use these 3 address spaces for internal networking in your organization. Now, why this was done was because IP version 4 had a limited address space. It has already expanded the number of internet connections. So when they brought in IP version 6, they says that IP version 6 is 128 and it is too large for the world to use up. So they brought in. But the problem that they faced was the moment you give IP version 6 addressing, you cannot have a private network versus a public network. The entire address space is now public in nature. You cannot do something called a network address translation. Okay, understood? Prakhar, for you it will be difficult. See, till now I said that all homes will have an internal address, and to speak outside you will go to the post office. Okay, but now I said okay, there is no differentiation between internal and external address. Everybody will have same address. So that means this post office is no more required who is doing the conversion. Now all packets can come straight away. That means now you cannot have a NAT kind of an arrangement, and that's why most of the enterprise have not used incorporate IP version 6 for internal networking. They are still reliant on IP version 4. IP version 6 is considered more or less a failure. I have not seen IP version 6 being implemented in enterprises till now. Right? It is used primarily for server networking. Maybe the cloud service providers are using, but enterprise networks are still running on IP version 4 because of this major problem of NAT. How do you distinguish between public traffic and private traffic? Okay, great. Now IP version, IP you divide it into certain classes: Class A network, Class B network, Class C network, Class D network, and Class E network based on the value of the first octet. Okay, first octet means the first 8 series. Okay, this determines what kind of a network is it. Class A network, are basically are the normal networks which everyone uses. Class B networks are used by service providers. Class C networks are used by ISPs. Okay, so that is how IP address space has been saved for the size of the network. Okay. IP classes, I told you, Class A network, first octet is occupied. Class B network, first 2 octets are occupied. Class C networks, first 3 octets are occupied. Okay. This is called a CIDR notation of a network. Most common protocols which are used on the network are something called the ICMP and IGMP. Okay. Now, ICMP and IGMP, they assist you in finding the health of the network. Okay, if they help you in assisting in finding you the network is alive or not. But these same protocols also lead to certain very, very huge vulnerabilities on the network by denial of service attack. Now, one of the most common way of finding out whether a website is working or not on the command line is ping. Okay, you write ping, okay, and write www.google.com. Right? If you get a ping command, that you know that okay, the website, the server which is hosting the website is working. Okay, now this is the most common way of finding out. Okay, but if everybody starts pinging the Google's server, what will happen is a denial of service attack will take place. Okay, so ICMP and IGMP, generally people stop at their firewall level so that no denial of service attacks take place. Right. Ping of death is an attack which happens once you send a bigger packet. Generally, a ping, you can modify the packet. You can send a 8-bit packet, you can send a 16-bit packet, you can send a 32-bit packet, you can send a 64-bit packet. When a malicious hacker sends a very big packet to the victim, what happens is the other end who's listening fails because it is not able to take so much of data and it fails. Such kind of an attack is called a ping of death attack. Then you have something called a Smurf attack. These are important. You should know. These are common attack tactics for denial of service attacks, right? Carried out on servers. Smurf attack is a hacker, it takes control of multiple PCs. It drops a Trojan to multiple PCs and asks those PCs to send a ping command to the target. So this is the ping. This is the target IP address, say 122.67.22.22. You tell everyone to send a ping command to this. So what happens? This target, it crashes. This is how you carry out a ICMP or a Smurf attack on a target server. Very common denial of service tactics. What do? You put a small firewall and say drop ping packets beyond certain rate. So beyond certain rate, you say stop ping. The moment you have more than 10 pings coming, you understand that it's a attack. So you start dropping those ping commands, ping requests. Then you have something called ping floods. Okay, one system, one bot is sending multiple ping requests to a target victim, right? I have put bots on 100 PCs and I'm telling those 100 PCs now send a ping request to the target. So there will be a flood of ping attacks on me. Okay, that is called a ping flood attack. ARP, I told you, address resolution protocol. It helps you in deducing the address of your local machines. If I change the table, I can redirect your complete data to a particular port of your switch. Okay, address the attack used to be called ARP poisoning. Earlier, switches didn't have too much of access control. You could access a switch directly. There was no username, there's no password in the switches. Slowly now the switches also have a lot of access control. You have username, you have password, you can implement MFA also on switches. Okay. Earlier generation 1 switches, you could access the switch directly without anything. Okay. You could access its ARP table without any username and password. And those days, such attacks were very common. These days, if you want to poison ARP, it is a sophisticated attack. Right. So these are the ARP concerns, right? You can spoof the ARP. Anything which is, is relying on a database, you can spoof it. The moment you crack its ARP is basically what? It is looking at port to MAC binding. So the moment you have this logic, you can force the packet to go to some other MAC. You put on this port, you put the same MAC address. Same MAC address, if I copy, all the data will go to one particular computer. Generally, the most common way of protecting switches against ARP attacks is by using called network intrusion detection systems, NIDS. Okay, so you use NIDS in front of the switches. This is the switch. You put NIDS on one of the ports, to check that your parameters of your switch are working fine. If not, then you launch a preventive action on the switch ARP table. Right, let's have a small question and then we will take a break. Okay, how you generally, DNS sec, it is a common thing, DNS security, right? So caching to speed up DNS response may not be the right answer, right? Okay, then to prevent phishing attacks by validating website certificates is not part of DNS security. Okay, but we have to do a little research whether it's part, but I'm aware it is not. It is basically the security of the DNS architecture, and that is basically to encrypt the DNS queries, okay, and to secure the infrastructure. But DNS queries is secured by DOH. So the right answer is B. You have to keep, taking the answers out. To secure the DNS infrastructure by providing authentication mechanism is the right answer. Okay.
Thank you for watching. Don't forget to subscribe our channel.